In this video, we're going to deduce the structure of C4H10O. Now, the NMR that we're going to do here has two singlets in it. Now, we've just zoomed in on that just to make it really clear it's a singlet. Okay, and we've got a singlet here, 9 and 1 as the relative peak areas, and we can get our chemical shifts from down there. So let's do the table. Okay, and in the table, we're going to do a peak splitting, and we're going to do the relative peak areas. So we've got to this point. Let's do the same thing we do with the n+1 rule, get used to doing this, and the hydrogen environment. So here's your hydrogen environment, it's 2, because we've got 2 peaks. And we've got n+1 equals 1, because it's a singlet. So 1 minus 1 means n equals 0, which means there's no hydrogens on the adjacent carbons with either of these. Now, an important thing here is this one down here, 2.3. Now that's a singlet with a 1, okay? And if you have a singlet with a 1, it's very characteristic. Singlet with a 1 that's very small like this, okay? It's usually an OH or an NH. Now we've got an O in there, so we're going to put that down as an OH, okay? So there's your OH. Now, let's look at the next one. If you've got a 9, now think about it, 9s can be divided by 3. Okay, so if you have any number that can be divided by 3, it usually means that it's a number of methyl groups in the same environment. So there's your kind of methyl group, and we think as 9, so therefore 9 divided by 3 means 3 different, three CH3s. Okay, and again, we're highlighting the hydrogens that make it. Remember, if you're doing it in the exam, you can underline it. You've got to highlight the H when you're doing this. Right, let's put this into a type of format which we can then decide on what the structure is. So let's put the table up, okay, and let's retain the information that we need, because you don't need the NMR anymore because we've got the table. We know there's 0, 100, or no hydrogens on the adjacent carbon for this one, so this must be connected to a carbon with no hydrogens on it because we are missing a carbon. See, there's 4 carbons in it. I've only accounted for 3 of them. Now, if that is the case, and let's draw it, this carbon must have no hydrogens on and have all the CH3s on. So let's put the CH3 on. Okay, and there's your CH3s. Okay, so we've got our CH3s, and that's that group at the top. So this group at the top here, we've done. We know that is bonded something else. Now, good thing is to count. So we've got C4H10. So we've got 1, 2, 3, 4. So we've accounted for all our carbons. 3, 6, 9. Okay, we've still got 1 hydrogen left, and we know we've got an OH. Well, the only way in which that can connect together is if I put the OH there. Okay? So you can figure out how to make the structure as long as you take the building blocks of each part and then add them together and see how they fit together. And in the coming videos, we will take these building blocks, and we'll take many more than just 2 building blocks. We'll take 3 or 4 building blocks and say, well, how does that fit together? Okay, and that's how it fit together. So the important thing is you know that 4 bonds to each carbon. Important that you can recognise an OH because you've recognised an OH in here. Okay, and it's important that you recognise characteristic groups like 3 methyls on a carbon with no hydrogens on it. Remember, it's a singlet because this carbon has no hydrogens on it. That's a singlet because it's an OH, and it doesn't peak split because of this blockage of the oxygen. But here you have your final answer, which is 2-methyl propan 2-ol. So let's summarise our learning from that NMR. So first of all, if you see a singlet with a relative peak area of 9, it's more than likely to be 3 times CH3s. And that CH3s will be bonded to a carbon with no hydrogens on it. Really important because it's a singlet like this. Okay, so you've got that kind of group. So really important that you know that. Look at this 9, straight away, brain goes, that's that group. Brilliant. Okay, next one is a peak with a relative peak area of 1 with a molecular formula including oxygen is likely to be an alcohol. Okay, and other things, it's likely to be quite broad at the bottom. Okay, and that is the 2 learning parts from here. Can you recognise an alcohol? Can you recognise these C3CH3s bonded to a carbon with no hydrogens on it?